So we're into 13.2, not 3.2, but 13.2. And we're going to define general angles. That means an angle of any measurement. Okay, so with the right triangle deal, here we had the old right triangle and 13.1, and we've had this before in geometry. And we got A, B, C, and let's say here's theta, and so here's the adjacent side, and here's the opposite side, and then here's the hypotenuse. Okay, and then we have to define the trig ratios as the ratios of the various sides. Okay, so here's where we're at so far. We have this anatomy. Now, theta can either be here or here, but theta is less than 90 and greater than 0, and that's it. Well, can angles be negative, or can they be bigger than 90, or whatever? Theta can go to positive infinity and to negative infinity. Theta can be theoretically anything, any real number. So, actually, well, we'll get into that. You'll get into that in pre-calc. It can be a complex number. All right, so use acute. So, before we use acute angles, these are acute, that is less than 90 degrees. Now we're going to do any angle we want, and we're also going to introduce this thing called radians, and you'll find out about that, and then we can do some cool things with it. Okay, so moving on from the triangular trigonometry, we are now going to use the coordinate system, the Cartesian coordinate system that you're so familiar with, and we will use rotation around this system beginning at 0, 90, 180, 270, and then 360, but actually and on to 450, and then 540, and 630, and then 720, and so in other words, angles can go on forever in either direction. Okay, so they can go positive or negative. All right, well, let's go back to our little drawing here. So we got to start over again because I scribbled all over that one. Okay, so we got 0, 90, 180, 270, and then let's say 360 is here and 0's here. Okay. So the positive side of the x-axis is called the initial side. Okay, so we have more anatomy here. Okay, we have the triangle, okay, hypotenuse, opposite, adjacent, A, B, C. Oh yeah, and little c, little a, and so A, B, and C, capital A, B, and C designate the angles, and little a, opposite A, is a side, and little c is a side opposite the hypotenuse, and little b is the side opposite. So we have designations, of the sides of the triangles. Now we're getting into the definition of how an angle is built. How an angle is built on the coordinate system. So we have the initial side, which is the positive side of the x-axis, always. Okay. So the angle. Now, if it's a positive angle, it's going to rotate counterclockwise. So counterclockwise is positive. And in case you're wondering, well, you can see the angles go in a positive and counterclockwise direction. 0 to 90 to 180 to 270 to 360, and on and on. Okay, so counterclockwise is positive, and then clockwise is negative. All right, and so the angle goes, as you can see in the drawing, and wherever it stops is the terminal side. Okay, and where the terminal side and the initial side meet is the vertex. And when the vertex is at 0, 0, the origin of the coordinate system, we call that standard position for the angle. Okay, and that's all there. Okay, so let's draw some angles in standard position. Now, let's you're watching this video or whatever, so then just do this, okay? So then you can look up your answer. So 240. Well, let's make it black again, okay? Draw the coordinate system. Now, don't worry about being exact. Now, don't get a protractor out or anything like that. Okay, but let's label it 0, 90, 180, 270, 360. Okay, so we start out the initial side. Now we're going to go red. Okay, the initial side right here. Okay, now we're going to start. It's positive, so we're going counterclockwise. So it's 90. There's 180. Okay, now if we go this far, it'll be 270. So how much further are we going to go? Well, we need to go about 60 more degrees. So about 2/3 of the way. I just make it approximate, okay? And we'll put the end of the angle, and here's the terminal side, and we'll label it 240 degrees, okay? No sweat. Next problem, 500 degrees, okay? So, and let's put the angle in black. Okay, initial side, we'll put 0, 90, 180, 270, 360. Okay, now we're going to start out. It's a positive angle, so we've gone 90, 180, 270, 360, but we're going to 500. So we're going to go another 90, and that'll be 450. Now we got 50 more degrees to go, so that'll be right about here. And we'll put our terminal side. Okay, and we'll call this 450 degrees. Okay. All right, minus 50. Let's make a coordinate system. Here's 0, 90, 180, 270, 360. All right, that's positive. Minus 50. Let's use purple. Okay, initial side, always the same. Now, going negative, 0, negative 90, negative 180, negative 270, negative 360. So in between here and here, between 0 and negative 90, it's going to be negative 50, right about here. And so we start at the initial side, and we go to the terminal side, and that's negative 50. All right. And you can check your answers over here and on to the next page. I gotta use some mouse to do that. Okay. Come on, next page. Oop, that went too far, I think. Okay. Now, coterminal angles. 500 and 140 are coterminal because their terminal sides coincide. And an angle coterminal with a given angle can be found by adding and subtracting multiples of 360. Now, what does that mean? Here. It's real simple. You don't want to get it wrong. Okay. Let's look at 45 degrees. Initial side, terminal side. 45 degrees. Now, what's an angle that would end in the same place? Well, if we took 45 degrees and we added 360 degrees to it, we get 405. Okay? So let's do 4. Now, 405 is going to begin in the same place. It's not going to begin at the terminal side. It's going to begin at the initial side because all angles begin in the same place. So we're going to go around to 360 and another 45 and they're at 405. And so 45 and 405 have the same terminal side. Okay, now what about a negative angle? This is 45, I got 450 degrees here. What the heck am I doing? That looks crazy. Okay, now let's suppose, how about a negative angle that ends at 45? Well, we'll take 45. Let's do red. Oh, no, not red. Let's do green. So we'll do, that can hardly see that. Purple. 45 minus 360. Okay, well that's like 5. So we take 5, 1, 215. Is that right? Oh, 315. Okay, so negative 315. So we're going to start at the initial side, and we're going to go clockwise, and we're going to go negative 90, negative 180, negative 270, and another 45, and that'll be negative 315. Okay? So 45, 405, and negative 315 all have the same termination. All right, they're coterminal. All right, now we got some practice here. And so we're going to draw a positive coterminal and a negative coterminal angle. So 65. Let's go black. Okay. All right. So let's do red. Okay, so we're going to do 65 degrees. That'll be about here. Okay, initial side, terminal side. 65 degrees. Okay. Now we're going to we'll do 365 360 plus 65, so 5, so that's 425. Let's double check. 360 plus 65, so we're adding 360 degrees to 65, and that'll be 425. And let's do that, let's blue. Okay, so that's a positive angle, so we're going to start here. 90, 180, 270, 360, and then plus 65 degrees. Let me draw the line out here, and the terminal side. Okay. And there we got 425. Yeah! Oh, I gotta go talk to my granddaughter on the computer. I'll be back. Okay, so that's 65 degrees with... Now, we're going to do a negative angle. Did we do that? 425. So we'll do 65 minus 360. So that'd be negative 295, right? Yep. Okay. So let's use blue. No, we already have blue. Green. Okay. Negative. So we're going to go counterclockwise, or clockwise, I should say. Clockwise. So this is negative 295. So we're going to go negative 90, negative 180, negative 270, negative 295 degrees. Okay? That's three angles, all terminal, one negative, the original angle, and one positive angle, all coterminal at the same place. Okay, 300. It's a positive angle. Initial side. Let's do it red. Okay, initial 90, 180, 270, and then 30 more degrees, so it's going to look like that. 270 degrees. Now, we'll add 360 to that. So 630 degrees. Okay, so let's make that blue. Okay, and so we're going to go 90, 180, 270, 360, 450, 540, and then what? 6, 9. Oh, that can't be right. Hang on a second. I gotta pause this for a minute. For some reason, I'm late. I don't know what the heck I'm doing. I drew the angle right, but this was 300 degrees, not 270. All right, so I'm taking 300 plus 360. which is 660. All right, so 540, and then plus 90, 630, and then 30 more degrees, and we got 660. Okay, so that's this angle right here. Now, we're going to subtract, so we'll take negative 360 plus 300, that'll be negative 60. And let's make that purple. So we'll start at the initial side, and we go negative 60 degrees, and there we are. Okay. 740. Now we're going to go around twice. 360, and then another 360, that's 720, and then 20 more degrees. To 740 degrees. Now you can see that we're going to have a positive angle that's coterminal with 20 degrees. Okay, so we don't need to go add 360 to 740 and then go around like all these times. All we need to do is add 20 degrees to it. And we get a coterminal angle. Now, we need a negative angle that's coterminal with it. Now, 720 goes around twice. So if we take 740 goes around. So if we subtract 360, we're going to get, what, 380. And we subtract another 360, then that's going to leave minus 20. So we actually have to subtract 360. That's going to leave positive 20. So we'd subtract another 360, and that'll leave negative 340. Okay, and then that'll do it for us. So let's use red. Okay, so we're going the negative direction. So we start at 0, negative 90, negative 180. Negative 270, and then negative 270, and then another 70 degrees to 340. Only that doesn't add up. Yeah, another 70 degrees will take me to negative, so here's negative 270 plus 7 is negative 340, and that leaves 20 degrees. Alright, so I've got three angles that are all terminal at the same place, positive 20, positive 740, and negative 340. Now notice to get to the negative 340, I had to subtract, because 740 goes around more than twice, I had to take 740 and subtract 3 times 360 in order to get a negative angle, negative 340, that was coterminal with it. If I just subtracted twice times 360, I would still end up with a positive angle. Alright. Now, this sort of thing, you can see, I'm making mistakes here while I'm doing this and everything. It's kind of confusing, but it's not all that important. I mean, it's important to recognize coterminal angles and all of that, but here's what's really important, radians. Radians we're going to be working with a lot. And what is a radian? Well, you can see it here on the circle. Okay. Now, if you take a circle and put the center of the circle, we'll call this circle in standard position. Why? Because the center of the circle is the center of the coordinate system. And then here's the radius, r. Now if you take r and measure it along the circumference of the circle, that's 1 radian. Now, because of the special relationship that pi has to In other words, the circumference equals 2 times the pi times the radius, 2 pi r, right? Therefore, there are 2 pi radians equals 360 degrees. In other words, the entire way around the circle. Now, usually we don't use the word radians. We just simply designate. So we'd say 2 pi, and we don't put anything else there. We just call it just 2 pi, and radians is sort of understood, equals 360 degrees. Okay, pi radians equals 180 degrees. Okay, so pi radians, which is 3.14 radians, 1, 2, 3, and then 0.14 here, is halfway around the circle. And another 3 and then a 0.14 radians goes the rest of the way around the circle. So 2 pi gets you all the way around. Okay, in terms of the number of degrees. So we can convert, we have a conversion factor. If we want to convert from degrees to radians, then we use pi over 180 degrees. If we want to convert from radians to degrees, we use 180 degrees over pi. These are the conversion factors because each one of these equals 1. So by using this as a conversion factor, we do not change the value of the fraction. All right, the value of the number, okay, or whatever. All right, let's go to the next page. And here's an example. Okay, convert 125 degrees to radians. Okay, now you can see it in the book or whatever. So we take 125 and we multiply it by pi over 180. But normally we'd write it like this. 125. We wouldn't bother putting the word radian in there. We'd do 125 over 1 times pi over 180. You'd write it like that. And then it's going to equal, you reduce it, 25 over 36 pi. We'll leave pi in the numerator. Okay, and then we got negative, notice when we got negative pi over 12, there's no mention of radians. So we're going to multiply this. Now, we want to go from radians to degrees, so we'll put degrees in the numerator and radians in the denominator. These cancel. The negative sign does not go away. 12 is going to go 15 times, so we got negative 15 degrees. Okay? All right. Negative 15 degrees. Now here's the list of the special angles. These are the angles that we work with a lot and for which we memorize the sine and cosine and all of that. So notice 0, 30 degrees, pi over 6, pi over 4, pi over 3, pi over 2, 90 degrees, 2/3 pi, 120, 3/4, and so on. Okay? So what are the denominators of the fractions? 6, 4, 3, 2, 3, 4, 6, 1. Okay. 6, 4, 3, 2, 3, 4, 6. There's a pattern. Just you do this enough, and you're going to see there's a pattern to all this stuff. Okay. So now we got some practice here. Convert the degree measure to radians. Okay, so we got 135 degrees over 1 times pi over 180 degrees. Cancel the degrees. We got 135 over 180. So let's see, 5 is going to go, what, 17? 5 goes into 135 17 times, and 5 goes into 180, let's see, 36 times. So 17 over 36 pi. You can double check that. I think that's right. Okay, so that's 5. 6, negative 50 degrees over 1 times pi over 360 degrees. Okay, the 0 cancels. And we have negative 5 over 36 pi. And that's about as far as we can go. 7, 5, now keep that pi in the numerator, over 4 times 180 degrees over pi. The pi's cancel. The 4 goes under 180. What? 45 times. Then we got 5 times 45, which is 225. So that's 225 degrees. Okay. And then 8, we got pi over 10 times 180 degrees over pi. Pi's cancel. 10, so we got 18 degrees. All right. Now, sectors of circles. A sector is a region of a circle bounded by an... So, here's a circle. Okay, a sector would be like this, section of the circle, like that. That would be a sector. Okay? And the central angle, here's theta, that's made by the two sides, the initial side and the terminal side on either side of the sector. Okay? And then, so sector, you can have the length here of the perimeter on the sector. You have the central angle, and then you can have an area formed by the sector. All right? So the arc length, this is called an arc. Okay, arc, A-R-C, equals, okay, S, we call it S, equals the radius times theta, but theta must be in radians. Okay? And the area, A, so we have A equals 1/2 r squared theta. Okay, now these are just plug and chug formulas, but again, theta must be in radians. So this is why it's good you know how to convert this, because now you can do some interesting problems. Converting. Okay, so example 4, we got softball field here. Okay, now we got, imagine, here, let's just look, here's the problem, like, in a more abstract form. The softball field is part of a circle. Sorry about that, it's really terrible. Circle, okay, and the radius of the circle is 180 feet. So we want to know the length of the outfield fence, and then we want to know the area of the whole field. Okay, so 90 degrees is the central angle, okay? And so we want to know the S, and then we want to know A. We want to know the area of the field. So S equals r theta, but theta has to be in radians. So we got 90 degrees over 1 times pi over 180. Okay, these cancel. So we got pi over 2. So S equals 180 over 1 times pi over 2, which will be 90 times pi. Now this we will convert. We're not going to leave this in pi form. Normally, if it's just a straight arithmetic question, we leave it in pi form. We will convert this. So we'll take 90, and then pi is second, and then up arrow, and there's pi, and we hit enter. And so the length of the outfield fence is approximately 283 feet. Okay, of the baseball diamond. Now let's get the area. The area equals 1/2 r squared theta. Okay, so it's going to equal 1/2 times 90 squared times, I'm sorry, 1/2 r squared theta times pi over 2. Okay, so it's going to equal 90 squared over 4 times pi. Okay, so we can just do this on the calculator. All right, so we got 90 squared divided by 4 times pi. Okay, now I know I did something wrong because it's a lot bigger than this. 1/2 r squared theta. R is 180, not 90. Okay.
Hey, it's Marge. So are you on your way? Oh, okay. I'll let her know.
Hold on, I want to do second.
Yeah, she's ready. She's
Okay. It's 180 squared divided by 4. Okay, and this is right. So that's approximately equal to the area, 25,447 square feet is the area of the field. Okay, so let's see if they've got any problems for us. All right. What if, an example 4, estimate the length of the outfield fence and the area of the field with the outfield fence is 220 feet from home field. So a bigger field, okay? So 220 feet. So R equals 220. So S equals R theta, which equals 220 over 1 times, still theta's the same, pi over 2. So it's 110 pi. So instead of, so let's clear this, 110 times pi. So S is approximately equal to about 346 feet. And then A, the area, equals 1/2 r squared theta. Now always write these formulas down when you're working on these problems because it will help you to remember them, which is going to equal 1/2 times 220 squared. I'll put that over 1 times pi over 2. So we got area is going to equal 220 squared over 4 times pi, which is approximately equal to, let's just get it on the calculator here. Okay, 220 squared divided by 4 times pi. Okay, about 38,013 feet. Square feet. Okay. All right. And that's it for now. You can start the homework.